In this tutorial video, I shall explain some questions from chapter Volume and Surface Areas, exercise 13.2. So watch the complete video. Let us see the second question of this exercise. Raquel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminium sheet. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of air contained in the model that Raquel made. So here in this question it is given that the engineering student was asked to make a model shaped like a cylinder with two cones attached at its two ends. So first of all we have to consider the cylindrical part of the model at its two ends. The first end is at the top while the second end is at the bottom. Two cones are attached, so first cone will be at the top, second cone will be at the bottom. Next line of the question, the diameter of the model is 3 centimeter. So here the diameter of this model is 3 centimeter, hence the radius of this conical portion will be equals to 1.5 centimeter, or we can say 3 upon 2 centimeter also. Either we can write 1.5 centimeter or we can write 3 upon 2 centimeter. Since the diameter is 3, hence the radius will be equals to 3 upon 2 centimeter. Next line of the question, and its length is 12 centimeter. The total length of this model is 12 centimeter, means from top to bottom the total length is given 12 centimeter. Next line of the question, if each cone has a height of 2 centimeter, the height of each cone is given 2 centimeter, means this height of the cone is 2 centimeter, height of this cone is also 2 centimeter. Then the height of this cylindrical part will be equals to 12 minus 2 minus 2. So it will be equals to 8 centimeter. Height of this cylindrical part will be equals to 8 centimeter. So let us see the solution of this question. In solution we can write that from the figure it can be observed that the height h1 of each conical part is equals to 2 centimeter. Here I have taken the height of each conical part is equals to h1. Now the second line we can write here, height h2 of cylindrical part that we have already calculated will be equals to 8 centimeter. Now the next line we can write, radius of cylindrical part will be equals to the radius of the conical part, because the base of both cylinder and the cone are equal, hence the radius will be equals to 3 upon 2 centimeter. Here we have to find the volume of air contained in this model. To find the volume of air present in the model, we have to find the volume of air contained in the cylinder, then volume of air contained in this cone, and then again volume of air contained in this cone also. So here next line we can write, volume of air present in the model will be equals to volume of cylinder plus 2 into volume of cones. Both cones are identical. This cone which is attached at the top and the second cone which is attached at the bottom, both are identical, hence the volume of both the cones will be equal. After that we have to write the volume of cylinder is equals to pi r square into h. Here the height of cylinder I have taken h2, so here we can write h2. Next 2 into volume of cone, as we know volume of cone is equals to 1 upon 3 pi r square into h1. Since the height of conical part we have taken h1, so here we can write h1. After that we have to put the value of radius and height in this equation. So the resultant equation will be like this. After solving this line we will have 18 pi plus 3 pi, that will be equals to 21 pi, and after solving this line we will get 21 into 22 upon 7. On the place of pi we can write 22 upon 7. 7 3s are 21, and finally we will have 66 centimeter cube. That is the volume of air present in this model. So this is the final solution of this question. Now let us consider question number 4 of the same exercise. A pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. The dimensions of the cuboids are 15 cm by 10 cm by 3.5 cm. The radius of each of the depressions is 0.5 cm and the depth is 1.4 cm. Find the volume of wood in the entire stand. So first of all, we will consider a pen stand which is cuboidal in shape. The dimension of this cuboid is given. Length is given 15 centimeter, breadth is given 10 centimeter, while the height of this cuboid is given 3.5 centimeter. The next line of the question is, this pen stand is having 4 depressions to hold the pens. The first depression is this one, this is the second depression, this is the third depression, and this is the fourth depression. Here each depression is in the shape of a cone. So here we can consider one cone. We have same type of cone in this depression. Here the dimension of this cone is also given. The radius of this depression is 0.5 centimeter, while the height of this depression is given 1.4 centimeter. Now let us see the solution of this question. Here we can write depth of each conical depression is 1.4 centimeter, while the radius of each conical depression is 0.5 centimeter. And as the length, breadth and height of this cuboid is already given. Now we have to find out the volume of wood which is required to make this pen holder. For this, we have to write the expression volume of wood will be equals to volume of cuboid minus 4 into volume of cones. It means if we will subtract all the 4 depressions from the cuboid, then we can get the volume of wood required to make this pen holder. Once again I am repeating this line, if we will subtract the volume of all these 4 depressions, because all these are the depressions, 4 depressions are there is no wood inside the depression, so we must subtract all these 4 depressions from the wood, then we can get the volume of wood required to make this pen holder. After that we write here volume of cuboid is equals to L into B into H, and volume of cone equals to 1 upon 3 pi r square h. The value of L, B and H is given, length, breadth and height both are given. So we can write here 15 into 10 into 3.5, and here the value of radius we are already having 0.5 centimeter, or we can say 1 upon 2, 0.5 centimeter or 1 upon 2 centimeter, while the height of conical depression is given 1.4 centimeter. So we can put here, after solving these two, we will have 525 minus 1.47. When we will subtract these two, then we will have 523.53 centimeter cube. So this is the volume of wood required to make this pen holder. Question number 5 of the same exercise. A vessel is in the form of an inverted cone. Its height is 8 centimeter and the radius of its top, which is open, is 5 centimeter. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. So here in this question it is given that there is a vessel which is in the form of inverted cone. So let us consider a vessel in the form of inverted cone. Here the radius of this vessel is given 5 centimeter, while the height, or we can say depth, is given 8 centimeter. Now the next line of the question is, it is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flows out. So let us consider a lead shot. Suppose this is the lead shot which we are putting it into the vessel. Whenever we will put this lead shot into the vessel, then the water will flows, because the water is filled up to the brim. It is already mentioned in the question. The water is filled up to the brim. So whenever we will put this lead shot into the vessel, then the water will flow out. Now let us see the solution of this question. In the very first line of the question, we can write height of the conical vessel, which is already given 8 centimeter, and radius of this conical vessel is 5 centimeter. It is already mentioned. So here I have taken R1, radius R1 for the conical vessel. Now the radius of the lead shot is given 0.5 centimeter. So here we can write radius R2 of lead shots is equals to 0.5 centimeter. Now here we have to find the number of lead shots dropped into the vessel. Suppose let n number of lead shots were dropped into the vessel. Here I have assumed let the number of lead shot is equals to n. Now according to the question, volume of water spilled will be equals to the volume of dropped lead shots. So here the volume of water spilled, or we can say flows out, is given 1/4 of the water flows out. It is mentioned here in the second last and last line, 1/4 of the water flows out. So here volume of water spilled, we can write here 1/4 of the volume of cone, and here volume of dropped lead shot. Since we are having n number of lead shot, so n multiplied by volume of one sphere. So the next equation we can write here, 1/4 of the volume of cone is equals to n into volume of sphere. After that, we will put the formula of volume of cone. As we know, volume of cone equals to 1 upon 3 pi r square h. Here the radius of conical vessel is r1, so we can write here r1 square. And volume of sphere we can write 4 upon 3 pi r cube. Since the radius of this lead shot I have taken r2, so here we can write r2 whole cube. After that, we will put the value of radius and height in the very first equation, and here again radius in the second equation. After putting the value, we will have this type of equation: 5 square into 8 equals to n into 16 into 0.5 cube. After solving this one, we will get the value of n is equals to 100. Hence, the final result will be the number of lead shots dropped into the vessel is equals to 100. Question number 7. A solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter, standing on a hemisphere of radius 60 centimeter, is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and its height is 180 centimeter. So according to the question, first of all we have to consider a right circular cylinder which is filled with water. Here in the last line of the question, it is mentioned that the radius of the cylinder is 60 centimeter. So here we can draw the radius, which is 60 centimeter in length. Total height of the cylinder is given 180 centimeter. So here we can write 180 centimeter is the height of this cylinder. So this is the total height of the cylinder, which is already given 180 centimeter. The very first line of the question is a solid consisting of right circular cone of height 120 centimeter and radius 60 centimeter standing on a hemisphere of radius 60 centimeter is placed upright in the right circular cylinder. So we have to put this solid into the cylinder. So let us see. This is the required solid. So we have put this solid into the cylinder. Here The height of the cone is given 120 centimeters. So here we can write the height of cone is 120 centimeter. It is already given here. Cone of height 120 centimeter. Radius is also given, that is 60 centimeters. So we can write here radius of this conical portion is 60 centimeter. Standing on the hemisphere of radius 60 centimeter. This cone is standing on the hemisphere, and this hemisphere is also having the radius that is equals to 60 centimeter. Now we have to find the volume of water left in the cylinder. If we put this solid into the cylinder, then we have to find the volume of water left in the cylinder, because whenever we are putting this solid into the cylindrical vessel, then some water will flows out. Then we have to find the volume of water left in the cylinder. So let us see the solution of this question. Here we can write radius r of hemispherical part will be equals to radius of the conical part, and both are equals to 60 centimeter, because the radius of hemisphere and cone both are equal. The next line we can write here, height of conical part is equals to 120 centimeter. It is already mentioned here. The next line we can write here, height of cylinder, which is already given 180 centimeter, and radius of cylinder is also given, that is equals to 60 centimeter. Now here we have to find out the volume of water left in the cylinder. So we can write here volume of water left will be equals to volume of cylinder minus volume of this solid. It means कि if we will subtract the volume of solid from the volume of cylinder, then we can find the volume of water left inside this cylinder. In the next line we will write the volume of cylinder will be as it is, there will be no change. On the place of volume of solid, we can write this solid is made up of conical portion as well as hemispherical portion also. So on the place of this volume of solid, we can write volume of cone plus volume of hemisphere. So in the next line we can write volume of cylinder minus, on the place of volume of solid I have written here volume of cone plus volume of hemisphere. After that we write the formula of volume of cylinder, volume of cone and volume of hemisphere. So here we can write pi r square into h1 minus 1 upon 3 pi r square into h2 plus 4 upon 3 pi r cube. After that we'll put the value of all the variables, and after solving this equation we will have pi into 60 square into 180 minus 80, and finally we will have pi into 3600 into 100, and after multiplying this one we will have the final result that will be equals to 1.131 meter cube. So this is the final solution of this question.